My dear students, today I am going to discuss about the basics of nucleophilic substitution reaction, which belongs to one of the most important types of organic reaction. In this video, I will cover the definition, types of nucleophilic substitution reaction and its mechanism, and lastly, a comparison between them. Now, I would like to tell you about the definition. In nucleophilic substitution reaction, an atom or group of a compound is replaced by a nucleophile. As you all know that nucleophiles are those substances which have affinity towards positive charge. This is the example of a nucleophilic substitution reaction. So here a nucleophile get attached to this positively charged carbon atom with its unshared electron pair and forming a covalent bond between this carbon atom and this incoming nucleophile, and the leaving group departs with its electron pair. In this reaction, this bromo group is the leaving group. There are two types of nucleophilic substitution reaction. One is unimolecular nucleophilic substitution reaction and another one is bimolecular nucleophilic substitution. And again, they can proceed through two different mechanisms. One is SN1 mechanism and another one is SN2 mechanism. Now, SN2 reaction, here S stands for substitution, N denotes for nucleophilic, and 2 denotes bimolecular reaction. This means that this SN2 reaction possesses two reactant molecules in the rate determining state. This is the example of a SN2 reaction where the bromo group of this bromomethane has been replaced by this hydroxyl group to form this product. This is methanol. Again, in this SN2 reaction, rate depends on concentration of both the reactant. For example, in this reaction, rate depends on concentration of this bromomethane and concentration of hydroxyl group. Here, the relative rates of some alkyl halides towards SN2 reactions are given. If we observe the value of relative rate, we will see that the relative rate value decreases from primary alkyl halides to tertiary alkyl halides. This indicates that SN2 reactions are more favorable for primary alkyl halides than the tertiary alkyl halides. In other words, when the hydrogen atom of these bromomethanes are replaced by methyl group, then the rate of the reaction is slowed down. Now, let us consider a reaction between bromomethane and a hydroxyl group in order to discuss the mechanism of SN2 reaction. As shown here, the hydroxyl ion attacks this carbon atom of bromomethane from the direction which is far away from the leaving group, that is from this bromo group, which leads to the formation of this 5-coordinated transition state where the bond between this carbon and the hydroxyl group is not completely formed and the bond between this carbon and this bromo group is not completely broken. After this bromo group leaves and form this product. This is methanol. One point which is to be noted here is that since incoming nucleophile attacks from the opposite direction of the leaving group, so the product is always formed with retention of configuration with respect to this reactant. Now, SN1 reaction. Similarly, here S stands for substitution and for nucleophilic, and 1 denotes for unimolecular reaction. In this reaction, the rate determining step possesses only one reactant molecule. This is the example of SN1 reaction. Again, in SN1 reaction, rate depends on concentration of only one reactant. So, in this example, rate depends on concentration of this 1-bromo-1,1-dimethyl ethane. Here, the relative rates of some alkyl halides towards SN1 reaction. Here we have seen that the rate is almost 0 for primary alkyl halides and the relative rate value gradually increases from secondary alkyl halides to tertiary alkyl halides. It indicates that second SN1 reactions are more favorable for tertiary alkyl halides. In other words, when the methyl group of this 1-bromo-1,1-dimethyl ethane are replaced by a hydrogen group, then the rate of the reaction is slow. Now consider the mechanism of SN1 reaction in case of reaction between 1-bromo-1,1-dimethyl ethane and water molecule. In the beginning, the bond between this carbon atom and the bromo group got broken to form a carbocation. This is the carbocation. After the formation of this carbocation, the nucleophile, which is water in this case, attached to this cationic carbon atom, followed by dissociation of proton to form this final product. Here dissociation of proton takes place. As we have already said that formation of carbocation occurs as intermediate in SN1 reaction after departure of the leaving group. However, the stereochemistry of the product got changed depending upon the attacking direction of nucleophile. As shown here, if the nucleophile attacks the carbocation from the front side, it results in the retention of configuration, and if it attacks from the rear side, then it results in the inversion of configuration. Therefore, in SN1 reaction always results in the formation of racemic mixture. Now, if we compare both SN1 and SN2 reaction, we will see that SN1 reaction is a two-step mechanism and SN2 reaction is a one-step mechanism. Again, SN1 possesses unimolecular rate determining step and SN2 reaction possesses a bimolecular rate determining step. In case of SN1 reaction, the product may be retained or inverted depending upon the reactant. But in case of SN2 reaction, the inversion of configuration of the product occurs. In case of SN1 reaction, the reactivity order decreases on going from tertiary alkyl halide to primary alkyl halides, while the reactivity order gets reversed in case of SN2 reaction. Thank you.